Okay, so now we are going to look at this graph here and answer these questions. So let's determine the velocity for the time interval of t equals 0 seconds to t equals 2 seconds for the student. So that t equals stuff just means time. So velocity from 0 to 2 seconds. Okay, so velocity is calculated the same way as speed, except for instead of distance, we're using displacement. But in this case, it's like the same thing. So if we're looking at speed, it's going to be distance divided by time. Distance divided by time equals speed. Okay, so the distance is 3 meters in 2 seconds. So 3 meters divided by 2 seconds equals, that's like 1.5 meters per second. Okay? So now we're going to determine the velocity for the time interval of t equals 4 seconds to t equals 6 seconds. So from here to here. Okay, so again, so we could write, actually I better write this the right way. This is displacement versus time equals velocity. Okay, but it's like the same equation, so don't be freaked out by it. Displacement divided by time equals velocity. Okay, so they moved, displacement just means how far they moved. They went from 3 meters to 6 meters, so all that means is just like 3 meters in 2 seconds. Okay, so that's another 1.5 meters per second. All right, so the average velocity, and something, I just did this in my head, but this is essentially that like y2 minus y1 over x2 minus x1. It's that same equation, and you can think about it in terms of all those numbers, or you can just kind of like see that that's what's going on there. This point minus that point, basically. Okay, so determine the average velocity for the time interval of t equals 0 seconds to t equals 6 seconds. Okay, so with velocity, again, we're looking at displacement, so we don't have to worry about like doing each one of these calculations. We just need to see like from there to there, what was the average velocity there? Like what was the speed there? So, so thinking about this again in terms of this is my y2, this is my y1, so 2 meters divided by, so 2 meters minus 0 meters divided by, let me put that in parentheses. So now I'm writing it out that way. Divided by 10 meters, or 10 seconds, minus 0 seconds. Equals, so that ends up being like 2 divided by 10. So that's like, what's that point? Let me just like double check. 2 divided by, okay, so it is 0.2. Part of me wanted to say 0.5, but it is 0.2 meters per second. Okay, that is the average velocity. Now, obviously, they did a lot of different, like if you were looking at distance, then that would be different, right? If we're looking at speed, that would be different. But average velocity, we're just taking into account displacement, so no big deal. Okay, what could the student be doing for the time interval of t equals 2 seconds to t equals 4 seconds? So I noticed during that time that time is going by, but their y position is not changing. So basically that means that they're just holding still for those 2 seconds. Slash chillin'. Okay, what is the total distance traveled by the student in the graph? Okay, so distance is the path length, so we're going to add each one of these together. So they go 3 meters, and then they chill, and then they go another 3 meters, so we're up to 6 meters, and then they chill. And then they go down, that looks like 4 meters. We've got 3 plus 4. And it doesn't matter that that's like a negative direction, because it's still like we're thinking about like how many steps they took, how long was that path. So it's 3 plus 3 plus 4, which is going to be 10 meters. What is the student's displacement? Total displacement. So we're looking at, they ended up 2 meters from where they started, so it doesn't matter that they did that whole thing. Their displacement is just 2 meters. Okay. So then, what's next? Okay, new graph. So during which time interval was the cart traveling its greatest speed? How did I know? So when I look at this, when we're talking about speed, we're thinking about the slope. So here the slope is flat, so they're not moving at all during that time. Then it kind of inclines a little bit, and then it's flat again. Then it inclines like a lot. And this one, so we're looking for the steepest slope. So I think that between F and G is the steepest slope, just looking at it like that. We could do some math about it too if we want to. Here, I'll pause it for a second. Well, no, I'll show you how to do the math here. So at this time, between 40 and 44 seconds, so in 4 seconds, they went 8 meters. So FG, they went 8 meters in 4 seconds, which equals 2 meters per second. Let's think about, so here in 10 seconds, they went from -2 to 8. So during DE, they went 10 meters in 10 seconds. So that equals 1 meter per second. So yeah, I was right when I eyeballed it and I saw that this was the steepest slope. That is true. That was their speed. That's where their speed was the greatest. Okay, I'll put that back. Okay, during which time interval was the cart traveling at its slowest but non-zero speed? How did we know? So a zero speed would be where these lines are flat. So not there, and not there. But of the places where this person was moving, they were moving the slowest between B and C, because that has the shallowest, or like the not steepest slope. So B, C. And we'll do some math about it just to prove it. So in 6 seconds, they moved 3 meters. Okay, so 3 meters in 6 seconds, and that equals 0.5 meters per second. Okay. And so we could also say that that has the shallowest slope. I don't know if that's the best way to say that. There's probably a better word for that, but I can't think of what it is right now. Okay, so during which time interval was the cart traveling at rest? How did I know? So there's a few of them here. It's any place where this line is flat. So between AB, CD, and EF, that cart is just holding still. And you can tell because time is going by, but their position is not changing. So that is a zero speed, or they're at rest. So during which time interval was the cart traveling in a negative direction? And how did you know? So traveling in a negative direction between F and G, because a negative direction means a negative slope, which is kind of like an inverse relationship, meaning that as time is going up, their distance from the start is going down. That gives it an inverse relationship, and that causes that negative slope. So we're going to say between F and G, because as time was going up, their distance was going down from the start. Was going down. Okay. Okay, last page here. What was the cart's velocity from 20 to 30 seconds? Okay, so velocity again is taking into account displacement over time. So velocity, and that's the same thing as speed over time. We're just thinking about displacement instead of distance. So velocity equals distance over time. So the distance is going to be from -2 to 8. So essentially that is 10, right? 10 meters in 10 seconds. So that is 1 meter per second. Okay. What was the total distance traveled by the cart during the entire 44-second long ride? Okay. So starting here, they moved 3 meters right there, then didn't move. Then they moved 10 meters right there, and then they moved 8 meters right there. So 3 plus 10 plus 8 equals 18 plus 3 is going to be 21 meters. What was the cart's average speed for the entire ride? So speed is taking into account distance. So 21 meters in 44 seconds. 21 divided by 44 is going to be 0.48 meters per second. What was the cart's displacement for the entire ride? So with this, we're looking at, so they started at -5 and they ended up at 0. So, so they moved +5 meters. Again, it doesn't really matter that they did this whole thing. When we're talking about displacement, it's just that snapshot. They started there and they ended there. They started at -5 meters and ended up at 0, so that is a change of +5 meters. Okay? So let's real quick go back and look at the answers that we have here. Okay, so we should have something that is 85 miles and something that is 135 miles. So I'll cross out these things that we have here. Okay, got that one. We got that one. Was it kilometers? That's fine. Okay, then we got 0 meters and 6 meters. Cool, got those. Okay, and then we got, okay, this one's not in the answer bank. This one's going to be 6.2 miles per hour. Yep, there's that one. All right, and we got 495 meters, and then this one is a difference of 0.3 hours. So 495 meters and 0.3 hours. And I actually got 0.2 hours, but that's close enough that we'll call it. Okay, so we got all our answers there. We are good. All right. Nice work. Good job, you guys.